I think most of us here are feeling sleepy. So I think I don't want to repeat the same things which most of the people have said. Everywhere it's MySQL, Postgres and TiDB. So I'll briefly tell more about our services. I'll spend more time on our services and less technically because most of the stuff have been covered already. So I started Mofare in 2008. It's almost like 16 years. We are a MySQL shop. We started as a MySQL shop, managing biggest of databases inside India. It's been 16 years. Our journey starting from MySQL, we went on to other technologies like Postgre, Mongo, Couch, Cassandra, Redis, Solar, lot of other technologies. And now here we are with things like TiDB and ClickHouse. So my passion towards cricket has made me go outside of MySQL and do something on the field. We started academy in Kanyakumari. We moved from 2011. We moved from Bangalore. We set up our base in Kanyakumari. Now we manage almost like 10,000 servers across 200 clients, across various verticals of databases we manage now. That's how we started this mirrorsports.com. Mirrorsports.com, we sell all the sports goods. Because of my passion towards cricket, we started selling all different types of sports goods online. And we did the entire flow of e-commerce platform, including warehousing and other stuff for homegrown, and we have done it. So about Mofare, like I said, we manage different verticals, different services, and we are a very small team of 75 plus members, sitting out of a tier 3 city and operating out some of the biggest giants, mostly around e-commerce, banking domains, and gaming platforms. So Yatra has been working with us for almost like 17 years. They are our first clients and they run huge platforms across Mongo and MySQL. So some of other clients are DTDC, Hindu, Shadi.com, NMS Works, Ecom Express. A lot more are there, but just we'll limit to that. So my agenda here will be, why MySQL? Why not outside the box of MySQL? What came next? And another one, a use case where we had looked at various factors that we considered before migrating out of MySQL and moving on to TiDB. And some of the features that we felt, that pushed us to go beyond MySQL. So, why MySQL? Somebody asked the question, why everybody is always asking MySQL. Early 2000s, there were only most of the databases were Oracle, MySQL, and Postgres. Postgres was very, very small. And that's why MySQL, most of the people talk about MySQL here because more than 2 decades, people use MySQL. That too for very, very enterprise-grade applications, very high transactional systems, handling terabytes of data. Almost all the workloads were running out of MySQL. You did not have a different database that could handle different verticals as you have the flexibility now. So it was only MySQL at that point in time. It was widely used, backed by strong community. Sun Microsystems took over, and from there Oracle, and now we are here. So this is some of the stats from DB engines that we took. This is the stats right now, which you are seeing. Even now, MySQL is there on some of the top. So MySQL, Microsoft SQL, Postgres, and MongoDB is still there. So that is why we are talking more about MySQL. What's changing here? Why now people are thinking different? We could see that there is a decline in pattern of MySQL users. The amount of people who have started moving out of MySQL, which means a lot of people are adopting some of the new technologies. That's what we are seeing here. Similarly, we also thought about, our customers. They had a lot of challenges. So we had to think about a different technology that would suit our customer requirements. So what was for one of the typical customers, this was the architecture that we were having. So they had a synchronous replication from master to multiple slaves. Couple of slaves were handling the transactional reads, and there were another 2 slaves which were handling the OLAP part of the system. So what was the challenges we were having is the MySQL data size was going huge. So which means we had to increase the hardware of the master, as well as as the number of slaves increases, we had to again bring up massive hardwares for us to manage. And the IOPS demand for processing the huge amount of data in MySQL. For example, one customer had terabyte of data out of MySQL. So processing that terabyte of data with MySQL, we had to bring in more IOPS, dedicated IOPS systems that had to do the aggregation part and things like that. And The only possibility of scaling out MySQL was, for the reads was, scaling out your read replicas. Again, it was additional cost. And how do you do that? Again, you have to take backups, restores them, spinning out was not that easy, not instantaneous. Things like that were again challenges to us. And the master slave, being asynchronous replication, there were always challenges in master slave replication lags. And coming to OLAP, the challenge was, very complex queries, so many joins across a lot of tables we had to do before, pushing that particular result set into the end user, result set has to be pushed out. It took us a lot of time because, we are joining terabytes of data across multiple tables. Adding more replica, again, restoring took us a lot of time, bringing up another load for a peak traffic. For example, say some customer might have a month-end traffic, some might have a festival traffic. Bringing out and spawning out a new replica was a bit time-consuming for us. Yes, we could speed up the analytics part by creating indexes, but again, the RAM part of it was going higher and higher. So we were searching for alternatives. So what all we considered before, what are the factors we considered? So we should have a scalable thing with a lot of write QPS. So MySQL architecture that we had was master with multiple reads. Scaling the writes was very challenging. So we were limited to a single master. So that was one part we had to consider. And the analytics, we were not able to do a real-time analytics with the current system. And the distributed architecture was again another challenge. To scale it horizontally, how do we scale it horizontally? That was again time-consuming for us. So we considered some of the top databases that were there: NoSQL, Postgres, ClickHouse, and Redshift. So NoSQL, it was MySQL compatible, but we had to do a lot of code changes for us to work on the similar system. If we were to do MySQL to NoSQL, it took us time. Postgres, again, it was powerful, but then code changes were more. ClickHouse, it was good for analytics, but it did not support OLTP. Redshift, it was optimized for analytics, but then the cost was very high. As the load increased, the amount of money we were spending on Redshift was very high. What we found was TiDB was a perfect fit and compatible with MySQL. Like somebody was telling, MySQL language that we used was very much compatible. A lot of the MySQL adapters we could use. So much compatibility. So we did not have to do, developer did not have to do a lot of coding changes to be compatible with TiDB. We were able to scale it very effortlessly. On the fly, we were able to provision nodes. It was able to behave like a truly distributed system. And thing is, it was a perfect combination for OLAP and OLTP. So these were some of the performance numbers benchmarking that we did for one of our customers. And that too specifically for a OLAP application. So we split our use cases into with aggregation, without aggregation, with joins, with group by, and then multi-level joins. So you could see the numbers here, right? As the amount of rows retrieved were less, the MySQL number were very closer to the TiDB numbers. But as we were increasing the complexity beyond, multiple joins across 5 tables, 10 tables, then what happens? With 10 crores of records, we were able to see almost like 100% consistently TiDB was performing much faster than MySQL. So that was very easy for us to show in terms of numbers, but again convincing a customer, yes, it was challenging to us. We had to show a lot of things before we convinced the customer to adopt TiDB. So what we had to do was, we told, let the primary data still remain in MySQL. We will have again, a asynchronous replica which we will set up to TiDB. And from there, we had to showcase to the customer, apple to apple, we were able to serve the traffic out of TiDB. So we set up a asynchronous replica using the DM. With zero downtime, we were able to set up blue-green at both the sides serving traffic on both the sides. And we were able to showcase to them, TiDB, we are comfortable with TiDB. We had to spend so much time on the POC to do that. So this DM, I think a lot of people talked about more about that. Specific here, I will come to here is, we were able to limit the DM, we were able to customize the DM that, specific rows we were able to pull. We were able to filter out certain conditions and push the data only into TiDB. So we were able to ignore which all row sets we do not want. We were able to put some conditioning around it, which was a better advantage when we were able to migrate to TiDB. So we did a one-time, full data migration and then incremental replication. We did a lot of parallelisms. When parallelism was implemented when migrating from MySQL to Postgres, and it was streaming on live. One more major feature that we used was our archival process generally truncates the data on the master. So we were able to ignore those things in the slave, which is on the TiDB, because we were going to use that for OLAP. And we were able to aggregate the full data set in the TiDB. And it was highly available, fault tolerant. I think everybody has talked a lot about that, so I'm just skipping that. So this was the architecture we migrated from. Initially, where we had 4 replica, we moved out to single replica with another cluster coming out of TiDB with 3 TiKV nodes and 2 TiFlash nodes. This was the architecture that we did, and we were able to show the customer that we were able to do blue and green approach. So what was the next challenge we faced was the cost. Why? Because even on top of TiDB, I'm going to fire a lot of aggregated queries, which was again, I need more nodes, more CPU, more RAM was needed for TiDB to be more operational. And because I'm going to run aggregated queries on top of that. So what we did, we went one step ahead of TiDB and we implemented something. We started implementing our own solution that could bring in CDC plus ETL. And what we did was we implemented a product called as Extreme. So what it does was, it reads the data from MySQL from the binary log. As and when any changes come into the database, we aggregated the reports that was needed on top of TiDB, and we created a flattened table on TiDB. So out of the major use cases, which were all very static for a customer, a number of repeated reports which were all needed, we pushed the result set from the binary log into the TiDB database. So which saved us our CPU costs and other optimizations we were able to do on real time in the destination TiDB. One more thing that we did when processing this data was, since that was a banking customer, we had to do some kind of compliance things. So we were able to mask the data. When we were moving out of database, we were able to do all the, when we were doing the aggregation, we were able to take care of compliance by aggregating or masking the data, and we pushed it back into the TiDB database. So it became a more secured environment on a real time. They were able to get real-time reports, close to real-time reports on TiDB. So the architecture we introduced on CDC and ETL processing Extreme, which was able to do that particular thing. So this was the final output that particular customer was running. So this gave us faster analytics with not having a very massive hardware on TiDB, but yes, we were able to do the compression and other stuff on TiDB, which saved the CPU cost on TiDB and took advantage of all the TiDB features. Thank you.